All right, this particular tutorial is for teachers of introductory statistics. Um, we lean pretty heavily on randomized simulation in order to get all of kind of the pedagogical gains and um, all of the big ideas of statistics laid out at the beginning of the course. And we do so by leaning on software. Now, in the past, we've leaned on Tinkerplots, but Tinkerplots is having issues with some of the newer operating systems, like the newer Mac operating system in particular. Plus, there's a small cost associated with it, even though it is pretty small. So the thing I'm going to actually walk you through is the StatKey simulation tools. Now, the StatKey tools are associated with the Lock 5 statistics textbook. So if you're using that book, that's perfectly fine. But you don't actually need to have the book or a license for the book to actually access this stuff. That's all for free. So you can see what I went to. I just Googled StatKey and it came up with this, lock5stat.com/StatKey. I'm going to show you the ones that are the most useful for me. So at the beginning of introductory statistics, the first thing that we focus on is single proportion hypothesis testing. So let's go into test for single proportion. Now, what this gives you is just a blank setup. Now it's associated with the book, and so there is a data set that it's associated with. I actually tend to just ignore that and just say, okay, I'm gonna put in a null hypothesis associated with whatever problem I'm dealing with. So say we're doing some sort of dice rolling problem, and it's, my null hypothesis is that it's a fair die, for example. And then if I do edit data, this is where I say, hey, I'm going to gather a sample. So let's roll the die 50 times. And let's say I get 12 ones or whatever it is I'm after. You press OK. So it tells me my proportion was 24%. Now, what I can do is I can generate randomized samples based on this null hypothesis. So all that's doing is saying, take that sample size and this null hypothesis and generate a sample. So I generate a handful of them. The nice thing that you can do in the StatKey simulation tools that you can't do in Tinkerplots is I just want to generate 1,000 of them, and another 1,000, and another 1,000, and another. And I can see the whole sampling distribution just kind of appear. So the thing that we were doing with software in the past is that we could only generate a couple hundred, and you didn't always actually see the sampling distribution in the way you want it. Now, furthermore, you can say, okay, well, the null hypothesis was 16%, and I got 24. So let's run a right-tailed test on this. So I click right-tailed, click on the proportion, change it to 24%, and it actually shows me my approximate p-value based on the simulated trials. So my approximate p-value here is 12%. So it looks like I don't have evidence that this is a weighted die of any sort. Okay, so this is the one proportion setup. The next thing I get to in my intro stat classes is the difference for two proportions. Now, I tend not to do simulation with this because the simulation setups are often a little bit complicated, but it's actually not so bad in StatKey. The null hypothesis is that they're equal. Okay, that's fine. That's always a null hypothesis. We're never going to change it. Again, this is set up with the stats or the Lock 5 stats book. So if you had their book, you could go for one of their examples. Again, I just ignore it and just say, okay, we've got two groups and we're checking to see if the groups are different from each other. I don't know, let's just say we've got two voting groups or whatever it is. So say I have 150 people in the first voting group and 34 of them are going to vote positive for whatever. And say I've got 127 people in the second voting group and 21 of them are going to vote positive. Whatever. I mean, it's a two proportion test, but this is putting in the sample sizes and then the counts so that we can calculate the proportions in the background. I'm going to press OK. Now it gives us the difference between my proportions. So it's about a 6% difference in my proportions. And now I'm going to build dot plots on this, but keep in mind that there's a couple ways that you can actually do these simulations. And I actually tend to do this on resampling, which is basically they're just doing bootstrapping in the background. We aggregate the 277 of these together and put the 54 of the positives randomly interspersed and just do random sampling of the two samples. with replacement. So it is truly a bootstrapping that's happening in the background. And so if I generate a few thousand samples, of course, our null hypothesis is 0. I had a 6%, so again, this one happens to be right-tailed. Let's say I wanted it to be two-tailed, for example, in this case. So I'll turn right-tailed off and turn two-tailed on. Right, and I can change my upper bound to 6.1%. Sometimes it's a little bit laggy, but that's okay. So I can see that my two tails together make up about, what, 20%. So that's the difference in two proportions. Now, typically in my intro stats, I don't do a ton of simulation beyond the proportion ones, but this particular tool has single means and two means as well. This is a little bit more complicated in that you've got to have data in here. So in this particular case, I'm just going to lean on the fact that I've got this temperature data from the Lock 5 book. And say I'm gathering samples from this temperature data, and I'm assuming that all of the humans in this data were normal, right? So I can generate a bunch of samples. This one's a little bit more annoying, again, because I can't actually just easily put my data in. But that's okay. We can still kind of do the same thing. So say we ran a test, and, you know, whatever. You can fiddle with this. You can see the probability, for example, of getting a temperature of 99, for example, right? And that probability is very, 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 very small. Again, this is based on some sort of bootstrapped resampling. Those are the ones that I use. I don't really even use the single mean, but for the intro stats class that we teach, the single proportion and the difference in two proportions works really darn well. There are ones for confidence intervals which don't assume a null hypothesis. So I went into single proportion. Notice there's no null hypothesis here. Let's just say we had 12 people out of, or 12 positives out of 50 in a sample, or whatever it is. And now I can build the sampling distribution around our data and actually look at the confidence interval in this way. So it's not quite the same as the tools we've used in the past, aka Tinker plots, but it works pretty darn well. So this is for all of those intro stats people out here who want a free and pretty powerful tool to supplement their randomized simulation. Cool, hope that helps.